Hello, I'm Rob McManus, a marketing manager at Red Hat. I'd like to explain how event-driven network automation can leverage intelligence and also analytics to assist in network deployment and operations. Event-driven network automation can manage massive amounts of complexity across both a virtualized and containerized network. It does so by automatically responding to events with a predefined response. So, how can service providers use this to quickly resolve network issues, avoid network configuration drift, enhance network tuning and capacity management, and also increase efficiency across their operational teams? Let me show you how event-driven automation solves these challenges by using a consistent automation platform across service provider networks. Expectations of high network service quality and also reliability drive the need for an accelerated response and also resolution of network issues. Event-driven automation provides a highly flexible solution connecting sources of events or alarms to corresponding actions. Let's take a look at how an event condition from a containerized network router can be mapped to an action that remediates that event condition. Network routers are deployed along with Google's Remote Procedure Call Network Management Interface, or GNMI, collector. This is used to collect streaming data from the network routers. This data is subsequently forwarded to a Kafka bus that is used by Red Hat's Event-Driven Ansible, and it uses this to listen for events such as network faults. When an event is identified, for example a router interface down alarm, it triggers a Red Hat Event-Driven Ansible rulebook. This in turn notifies Red Hat Ansible Automation Platform to run a respective playbook to automatically bring the router interface back up. Let's now create a network environment to demonstrate the power of event-driven automation. Provisioning of the network topology is achieved using OpenConfig Kubernetes emulation. This creates an extensible operating system and also the service Linux for the two network routers. Pods for both routers can be seen from the Red Hat OpenShift console. Pod R1 is for one of the routers and Pod R2 is the second router. The GNMI collector is deployed in another pod. Configuration of the GNMI collector allows it to subscribe to both routers' interface status. Using the network logs, we can see the GNMI collector has been connected to the Kafka bus and is also connected to both of the routers. A Kafka cluster has been deployed in advance and leverages Red Hat AMQ streams for the Kafka bus. Let's now see event-driven automation in action. We simulate a network failure event using the terminal capability within Red Hat OpenShift. The command line interface is used to shut down the interfaces of one of the routers. A Red Hat Event-Driven Ansible rulebook has been created, and via GNMI and the Kafka bus is listening for events, including the router interface status changes. Events can be seen from the rule audit view within Red Hat Event-Driven Ansible. At the top of the list is the interface down event that we previously executed. The router interface down event has automatically triggered the rulebook and the playbook, and this has reconfigured the system, and in this example, bringing the router's interface back up. The rulebook job template can be seen from the Actions view within Red Hat Event-Driven Ansible. All event data is available, including the source of the event, the interface name that is triggering that event, the admin status, and the status value of the interface itself. From the output log, we can see the outcome of the closed loop execution. The router's Ethernet interface is now enabled, whereas before it wasn't. Executing automation at scale and not limiting it to individual tasks drives a number of benefits. These include significantly reducing operational expenses, increasing revenue, and allowing service providers to meet their own and also mandated policy compliance and regulations. Red Hat's approach to automation extends past networks to include workflows, applications, infrastructure, and also open hybrid cloud security. We provide trusted closed-loop automation solutions that help service providers streamline their hybrid environments their automation strategy, and also their application development. To learn more, contact us today.